Good morning, students.
Good morning, sir.
Thank you, Asha. So, good morning, one and all. So, first of all, sorry for the inconvenience that the yesterday I couldn't take the class, and I requested ma'am to handle the class. So, hence I am taking her class today. The information is there won't be any test from Monday, so that you already know, and also the postponed dates for the first test, and also with respect to the examination of the first semester. So regarding that, there is a meeting according to our coordinator. So as the information provided by the coordinator, there will be a meeting on Monday. So in that Monday, they probably may discuss. So their discussion and their conclusion is based on what today the government of Karnataka gonna decide with respect to the lockdown, especially in the Mysore district. So in what way they are going to release it, or will they continue, or what? So we have to wait and see. Based on that, the university will take the call. So as the university immediately takes the call, we will let you know. So what's the decision like? Now, with respect to the lab, today I will share the link to the Torsional Pendulum. So I had asked Arshad on that date. In fact, he had called me, but due to some unavailability and due to some work, I couldn't pick the call. So I will instruct the CR to share the link among 5 people, and those 5 people will share the links to the remaining 5 people. So individually, I cannot share to all because the number of sharing is limited. So I cannot permit all to look into the video, to edit, or to download. So I can ask only up to 20 people, I think. So I will share it to the CR. CR will share it to any 5 members, and those 5 members will share it to the other 5 members. Likewise, you need to share that link, and then only you can access to the videos with respect to the lab. Now, with respect to the theory, we are already started the unit 2 and chapter 1 electrical conductivity, and we have gone too far into that. The syllabus for the first test, if the first test will be held, if it is held in next week or any other week, the syllabus will remain the same. That is the quantum mechanics. We won't highlight the syllabus. Yeah, why? Because it will become too huge. So we have discussed in our departmental meeting that we should not ask everything, whatever that we have discussed in the class till that date. So we have to go in a very cumulative way. So we won't give much of syllabus to cover for the first test or the second test. You need not to worry. If the college takes the decision like event should be conducted, not the test, then we go with the assignment or we go with the numericals. We are waiting for the circular from the higher authority. Once we get, we definitely will share among yourselves. So please bear with us. It's an ambiguity will be there. It's a what I say, what I can call is it's something like a transition period. Nothing is clear. So yeah, do we have to sit quiet or do we have to prepare for the test? So this ambiguity will be there. We have to cooperate with this. Why? Because we request your cooperation in this. Why? Because it's a must that the situation is very critical and we have to cope up with the situation and we have to go hand in hand. So please keep studying. The materials have been shared to you. Go through the materials and prepare accordingly. If any test or any examination falls at any time, if you are prepared, then it would be easy for you. So don't wait till the announcement comes. Please keep preparing every day by day. So for all the subjects, okay. Uh, Now let's start the session.
This call is now being recorded.
Now the electrical conductivity, we have been discussing the electrical conductivity in the last class, and we discussed a very important event, so the concept under the electrical conductivity. which is a very important concept, which is applicable to all the science branch and all the engineering branch. It is the basic, but it doesn't look like so. It's just a simple mathematical calculation and analytical way of assuming the energy level. So we have discussed this quantum theory of under the quantum theory of electrical conductivity. We discussed density of states, and we also saw how the one dimension, two dimension, three dimension, and also the zero dimension can be used, how this density of state function varies with respect to all these the four cases. And all put together, we also saw the graph, how does it look like, the variation, the density of states. And we also came across something called k-space. It's nothing but plotting the energy in the terms of wave vector. K-space means wave vector space. So E is equal to K. So that is, energy is directly proportional to the wave vector. Therefore, when two parameters are directly proportional to each other, we can discuss the parameter of one with respect to the or in the space of the other. So I can discuss about wave vector in the energy space, or else I can discuss about energy in wave vector space. So that is one of the concepts that we have taken from the quantum mechanical basic postulates. And we proceeded further and stating that every space point represented, since energy is directly proportional to the wave vector k, that wave vector k is directly proportional to the quantum number n. So since the quantum number n stands the energy states, at every value of k or at every value of n, we find an energy level E. And the number of energy level within any energy is number nothing but density of states. And we also discussed about how to consider two spheres with the different energies and different radius vector. And we represented this radius vector in terms of the quantum numbers, the principal quantum number, which represents the energy states. So we took the three-dimensional case. So using the simple statistics, we had derived the expression for the density of states as 8 root 2 pi m to the power of 3 by 2 h cube e to the power of half d. So this is the expression here, the written at the bottom. This is the density of state expression, or density of state simply. Here remember, 8 is constant, everything is constant. The only variable here is E, the energy E. Therefore, the density of state function GE depends mainly on the energy. That is, G of E is directly proportional to square root of E. Okay, G of E is directly proportional to square root of E. Now, that means from which energy level you are counting the number of states also matters. What does it mean? Means the number of energy level will not be same for any energy value that you take inside a material. Inside a material, if you take any energy value, from that energy value, if you want to count the numbers, that will be different from another energy value if you are counting for the same material in a different energy state, from a different energy state. So if you start counting from the ground state to first energy state, or the first excited state, sorry, the number of energy levels available between the ground state and the what I can say, the first excited state or the second excited state will be different. And also the number of energy levels from the second excited state to the third excited state will also be different. So it depends from where you are starting the counting. Are you counting from the ground state? Are you counting from the first state? Likewise. So here we won't go with the state, but instead we say it as from the position of the band. Are you counting in the valence band? Are you counting in the filled band? Are you counting in the conduction band? Likewise. So instead of energy states, we use the word bands. So energy in a band, energy in a filled band, energy in a valence band, energy in a conduction band. Likewise, presented this various vector. So from where you are counting, from there the number of energy level changes. If you are counting from the bottom, energy level increases. If you are counting from the top, the number of energy level will be somewhat different. Okay, so this depends on the material, what metal it is, an aluminum, copper, iron, what metal. So depending on the energy number differences. Okay, now this is regarding the uh, density of state equation which we derived in the last class. So in the now let's move on to a very important concept called Fermi energy. So every material characterization, if you after the completion of BE and if you are doing MTech, or if you are doing MS or or if you are doing a doctoral degree or even postdoctoral degree, this word, the Fermi energy, will haunt you. Why? Because based on this only you will classify the materials. Based on the classification of the materials, you will classify the materials. Based on the characteristic of a material, you will decide a property of the material. Only once when you define the property of the material, then only you will use it for so and so application. If you are using a ceramic for high voltage application, someone will ask why. Then you will start explaining. So when you start explaining, you will use the word Fermi energy, obviously. Okay, you will use the word Fermi energy. And if you are using, or if you are working for a KPTCL, if you are using an oil shields for the high voltage discharge to be controlled, someone asks why oil shield. So then you will start explaining what is a high voltage discharge, what it does to the material, why there will be a spark. So there also you will use the word Fermi energy. So if you are remember, remember, definitely you will be coming across these words, but not exactly as Fermi energy, but something other than this, something a word with us just replacing Fermi. So you may call it as cutoff energy or cutoff voltage. So that's it. So here in a physics way, we define the concepts based on the inventors. As an engineer, you will define the concepts based on what output or what instrument that you are using. If a voltage breakdown does, and if you are measuring the voltage breakdown using the voltmeter, then you call it as cutoff voltage, and we call it as saturation. Okay, so you may call it as cutoff voltage, we call it as saturation. Something, an alternate word in engineering is always there, and it always exists, and which you will be using. But they represents these concepts only.
Excuse me,
Now,
sir.
yeah,
Someone wants to join.
let me see. So this diagram you have seen in your +1, which is nothing but an energy level diagram. When you're plotting a graph of energy versus the radial distance, so remember, you're plotting the energy along the x-axis. So this is the energy value along the x-axis. Okay, and you are plotting along the y-axis. What is this along the y-axis? You are plotting the radial distance. Okay, so I will put it as r vector. So radial distance is r vector and e. What is this radial distance? Distance of an electron from the nucleus. So when you are plotting the graph of distance of the electron from the nucleus versus the energy of the electron, then you will get to see that the energy level or the will be like a straight line. These are nothing but the energy levels, and the gap between the energy levels are different from one another. So that is evident from your Bohr theory, and one can see that the topmost energy level that the electron can have corresponds to an energy which is 0 electron. Okay. Further, when you apply the energy, the electron will detach from the metal and it becomes free electron. So this is the topmost energy, the potential energy. So as you go near to the media, energy drops. Okay, the potential energy drops and the energy will be aligning like this. So a plot of radial distance of the electron from the nucleus versus its potential will be as energy level diagram. Okay, so why an energy level exists? An energy level exists because of an influence of a proton over an electron. An influence of a proton over an electron. Now I will just, I would like to take back slightly to the concept like hybridization, which you have learned in your +1 and +2. So after this we go. Remember, at an absolute zero, all the electronic states of the valence band are full and those of conduction band are completely empty. So this you know with respect to the band theory. In the case of a metal, the valence band will be partially full and the free band will be completely full and the conduction band will be completely empty. And also, classically, all electrons have zero energy at 0 Kelvin. So it is tend to say that it is having zero energy at 0 Kelvin. But it is not so. Remember, no electron exists with zero energy. they may exist with zero potential energy. I'm not talking about the total energy. There will be an electron with zero potential energy, but not total energy. So no particle like electron exists with zero energy, even though the temperature is 0 Kelvin. But that is classical mechanics. Classical mechanics tells that the electrons have zero energy at 0 Kelvin. But quantum mechanics says that all the electrons are not having zero energy at 0 Kelvin. Okay, so it's not necessary that every electron should have a lowest energy when the temperature is low. Even at the lowest, I can have zero energy state, first excited state, second excited state. So the energy value changes from one level to the another energy level. That is the quantum mechanical explanation. The maximum energy that the electron may possess at 0 Kelvin is the Fermi energy. So that is the main definition of the Fermi energy. So one can see here in this plot that, so I am just talking about this plot. Let us say the temperature is T is equal to 0 Kelvin. Okay, let us say the temperature is 0 Kelvin. That means 0 Kelvin means it is not minus 273 degrees Celsius. T is equal to 0 Kelvin says that the temperature surrounding this metal, let me be